All right, 4.4 part 2, where we look at SSS and SAS. Right, so you should have the handout that looks like this if you're in class with me. If you're absent or rewatching this, then you just have to write everything. Okay? SSS, side, side, side. Side, side, side. Side, side, side similarity. SSS. Alright, if all corresponding sides are proportional, then the triangles are similar. All of the sides have to be proportional, meaning they all have to have the same ratio. Right? They all have to have the same ratio. Which means that A over B has to equal C over D, has to equal E over F. All three sides have to be equal. They have to have the same ratio. Right? So, determine if the example below are similar by side, side, side similarity. If yes, write a similarity statement. Awesome. So, all we have to do is look at the sides, the corresponding sides, and see what the ratios are. That side matches that side. 3 to 6 is that ratio. This side matches this side. 4 to 8 is that ratio. This side matches this side. 5 to 10 is that ratio. We have the ratios. In order to see if they're the same, we need to simplify. This is why I keep stressing simplify. All you need to do is simplify. Both can be divided by 2. That leaves you with 1/2. Both can be divided by 2. That leaves you with 1/2. Both can be divided by 2. That leaves you with 1/2. Look. These are my ratios. 1/2, 1/2, 1/2. 1 to 2, 1 to 2, 1 to 2. All three of my ratios are equal. That means that my corresponding sides are proportional. That means they are similar, because you have to have all three of them be equal. All three of them. So we can write our statement. Match up your angles. P and S, R and U, Q and T. Don't forget your symbol. That's your answer. Yes, they're similar, and this is our evidence. This is proving your work. Find the ratio, simplify, and decide if they're equal. That's it. Side, side, side. Another. Same thing. Find your corresponding angles. Right? 30 over 24. 35 over 28. 32 over 25. Doesn't matter which triangle you start with. No, you choose, because it didn't tell you which one to start with. Just remember, whichever one you start with, you have to start with that one all 3 times. Right? I start on the left because that's how you read a book. Why make it complicated? All right, now we need to simplify. Both of these can be divided by 6. So it's going to be 5 over 4. Both of these can be divided by 7. Because we're dividing them by the same number, we're not changing the fraction. We're creating an equivalent fraction. We're just simplifying it. We're not actually changing anything. But it only works if you divide the top and the bottom by the same number. And that leaves you with 5 over 4. Oh, it's looking good so far. Both of these can be divided by Uh-oh. 32 over 25 can't be simplified. Can it? What are my factors of 25? 1, 5, and 25. None of those go into 32. So this one can't be simplified, which means it's not equal. Right? It's not equal, which means they are not similar. If they are not equal, you just say not similar. And this is your evidence. They look similar, but they're not. We proved it. All right, pause it and come back and ask for number 7. Ask for number 7. All right, welcome back. And on number 7, we're going to do it again. Directions say determine whether the triangles are similar by side, side, side. It literally tells you side, side, side. If yes, write a similarity statement. All right, let's find our ratios. It looks like to stack it, we would need to rotate. So 20 over 25, no, 2025 over 31.5. Don't panic about the decimal. Decimals exist, y'all. Decimals is just, you know, money. 50 cents, 0.50. All right, let's see. That one matched that one. So if I flip, then 9 over 14. You notice there's no equal sign yet because I don't know if they're equal. Don't put the equal sign until you're sure. And then 13.5 over 21. All right, look, to find out, don't even try to simplify those fractions. There's decimals in there. Brain hurts, right? So instead of trying to simplify them, just divide them, because a fraction is just division, right? Get the actual division, get the actual decimal answer, and see if they're all the same. So 20.25 see that calculator. I'm getting all going blind. Divided by, right? 20.25 divided by, that's what the fraction bar means, divided by 31.5. You should get a really weird number. So 0.64287, it keeps going, right? We just need enough to know if it matches. We just need enough. 9 divided by 14, it's the same number. 0.64287, right? But remember, we have to have SSS. We have to have all 3 be proportional, so we have to do all 3. 13.5 divided by 21. It's the same number. 64287, blah, blah, blah. So, yes, they match. Let's write our statement. And because I did this in different colors, I already know. No, it's all right. Let that go. So, when let's do them in green. So this angle matches this angle, right? Because when I spun it, I rotated it. So N and E. And because I rotated it basically upside down, then this angle matches this angle. So R and S which leaves us with K and D. Just like that. Similarity statement, because they're similar. We've proved it, side, side, side. All three sides are proportional. They look very different on the fraction, but once we divided it on the calculator, we realized they were all the same. Do number 8 on the handout. Show your work. Get it right, get a smiley. Move on to the practice sheet number 9 and 10. Again, go ahead and do 9 and 10 before we come back to the video. Do 9 and 10, then come back to the video. But don't move on from 9 and 10. Just do 9 and 10 and then come back to the video. All right, and last method is SAS, side angle side. Right, I'm gonna fix that. I don't like it. I don't want you to see that. I mean, you obviously saw it, but I don't want you to. I want to have space to work. That makes sense. I was trying to say that. It was hard to say. Don't judge me. All right, so SAS, side angle side similarity. Side angle side similarity says if two corresponding sides are proportional, so you need two sides that have the same ratio. Two sides, two corresponding sides that have the same ratio, and the included angles are congruent. So if the vertex between those two corresponding sides, if the vertex between those two corresponding sides are congruent, then the triangles are similar. So side angle side, right? Side angle side. So let's see what that looks like. Determine if the examples below are similar by SAS similarity. If yes, write a similarity statement. So we have to use what they're giving us and fill in the blanks. Right? So they gave us sides, and this is the angle, the vertex in between. Right? So we have everything we need. Now we just need to figure out if the sides are proportional. So we need to find the ratio. So this side matches this side. So 8/6. This side matches this side. 20/15. Let's find the ratios. We simplify, right? Divide both by 2. Divide both by 5. Okay. We can keep going because we have equal ratios. The corresponding sides are proportional. So we can keep going. Right? The corresponding sides are proportional. So now we need to see if the angles are congruent. This line tells me that they are congruent. If the angles are congruent, and this proves it, then they're similar. The angles are congruent. If it had numbers on them, if it said that this was 12 degrees and this was 12 degrees, that's equal, congruent. This also means they are congruent. But they have to have the same number. They have to match. We're looking for a pair there. All right? So yes, it's similar. Now all we have to do is write our statement. Match up your angles carefully, y'all. JM LP, order matters. KN. Done. They are similar, and we proved it.
All test administrators, proctors, and hall proctors should report to the library at this time. Again, all test administrators, proctors, and hall proctors should report to the library at this time.
Give me 5 minutes, man. 5 minutes. All right. This one has more information, but you just have to think about it. The triangles are already stacked for you. They're two separate triangles. There's a smaller triangle, and there's a bigger triangle, and they're stacked on top of each other. Okay. So, let's ask ourselves the corresponding sides, right? They're literally right here for you. 25 over 15. And I did the big triangle first, which means I need to do the big triangle first. 21 over 12. Simplified. Let me give you some space there. What is it? 21 over 12. Both of these can be divided by 5. Both of these can be divided by 3.
Pardon the interruption. Teachers who are not testing, or you have not, we know we have not started, check your emails. Please check your emails to see if you need to send a student evaluation, and check your emails after testing to see if you need to send a student evaluation. Thank you.
21 over 12, yeah. Simplified, this would be 7 over 3. You could stop right there, because 5 over 3 does not equal 7 over 3. The sides are not, the corresponding sides are not proportional. The ratio does not match, right? So 5 over 3 does not equal 7 over 3. So they are not similar. They are not similar. Interesting. You would think they are because they're stacked. But if you were to figure out the actual angles of the triangles, they would be different. But you have to be able to prove it. Right? So, pause it, come back, and ask for number 13. Ask for number 13. Welcome back. All right, let's do one. Let's see what we know, what we don't know. It tells us to do side angle side, so we need to find corresponding sides. To stack them, I would rotate. This goes with this. So 24 over 6. First shape, second shape, just as a reminder for myself. So 48 over 12. Simplify. 24 divided by 6 is 4. Whole number. 48 divided by 12, 12, 24, 36, 48 is 4. 4 equals 4. So my ratio is good. My ratio is congruent, so I can keep going. Now I need to find out if we have side side, we need to see if there's an angle matching. Remember, if they are diagonal across from each other, they are vertical angles, and vertical angles are congruent. So yes, this is my evidence. We have side, angle, side, which means they are similar. Now we just have to match up our angles. Sometimes that's the hardest part. All right, use what you know. I know these are the same. So E and E. When I rotate, S lands on G. S lands on G. That leaves me with, oh wait, be careful. This is my second shape. S lands on G, so, or G lands on S. Be careful, order matters. That leaves me with F and R. Be careful. I could have made this the first shape because it's on the left. I don't know why I made that one the first shape. You just have to be consistent. Okay? Watch it again, babies. Watch it again. Do number 14 on the handout. Show your work. Get a smiley. Glue it in. Finish the practice sheet. Do numbers 15 and 16. Go back and make sure the practice sheet is complete and that you're comfortable with the material before you come and get your mastery check. Be ready. Watch another video. Rewatch this video. Ask a neighbor. Double check. Help each other. Then come get the mastery check when you're ready.